All right, now we're going to get fancy. So you might recognize that this example is a lot like example 2. In example 2, we were asked to find a linear polynomial that approximated the function near x equals a, and we were trying to match the value of the polynomial to the value of the function and the first derivative of the polynomial to the value of the function. Now we're just going to take it one step further. All right, now we're going to try to find a quadratic polynomial, right? So second degree polynomial. And we want the value of the function the value of the polynomial to match the value of the function. We want the first derivative of the polynomial to match the derivative of the function. And now we want the second derivative of the polynomial to also match the value of the function. Okay, so we're just taking example 2 one step further. All right, but let's go through the same process here. The first thing is that we want the value of the polynomial at a to match the value of the function at a. So the first thing I'm going to do is just put in x equals a into this polynomial. And you'll see that, okay, we have a and then x minus a, right? Because if x is a, well, here, I'll just go ahead and write it out. We're going to have b times a minus a, and then we're going to have c times a minus a squared. Well, a minus a, right, is just 0. So all we get is a, and that's telling us now that this a value has to be f at a, right, because I want the value of the polynomial to match the value of the function. All right, so we have we have a now. All right, so now we have to take the derivative, and it might be helpful to write this out since it'd be easier to take the derivative if we distribute this. It becomes bx minus b times a, and then we can, well, let's see, we need to FOIL this out, so we're going to get x squared minus 2ax plus a squared, right? And then we could distribute this c all the way through. All right, so let's find p prime, the second degree polynomial. Find the derivative of this polynomial. Okay, so the derivative of a is 0, and then the derivative of bx is just going to be b, and then now I didn't distribute this out, but you could imagine this next term is going to be cx squared. So we're going to have, let's see, we're going to have 2cx. All right. The next term is going to be 2a times c times x. So the next term will just be equal to, it's going to be a minus. We're going to have 2a times c, and then the derivative of x is 1. And the last term is going to be ca squared, which is a constant, and so that the derivative of that is 0. Okay. Now, when I put in x equals a, all right, so let me put that down here. P prime of the second degree polynomial at a, I'm going to get b plus 2 ca minus 2 ca and ac are the same. So I could write it that way if I want to. And then you can see these are going to cancel. So I just get b. All right. So now remember, I want the, this is at a. I evaluated it at a, didn't I? This is a. P prime at a. All right. So now remember, I wanted that to equal f prime at a. Okay, so just like we had before, we have a equals f of a and b equals f prime of a. So that looks familiar, right? All right, let's look at the second derivative now. All right, let's look at the second derivative of this polynomial, the second order polynomial, second degree polynomial. Let's do it at x. So let's go back up to our first derivative and take the derivative of that. So I have b, right? The derivative of that is 0. 2cx, so the derivative of that is 2c. And the derivative of this last thing, 2ac, that's just a constant, right? So that's 0. So my second derivative is just 2c. And now the second derivative is just a constant, and I want, so I know that, let's write it down here, I'll write it here. P2 second derivative at a is just 2c, right? Doesn't matter what a is, or what x is. It's always going to be 2c, and I want that to be f double prime at a, okay? So I need c, so I'm just going to divide both sides by 2, and I get c is equal to 1/2 times the derivative at a, or second derivative at a. All right, so we have a, and we have b, and we have c. They're all in terms of the derivatives of the function f at a, but we can write this out. We have the second order polynomial of x, now that we know a, that capital A was f of a, so we have f of a, and then plus f prime at a times x minus a. So that right there looks like our linear approximation. But now we're going to add another term. The next term, if we want a quadratic approximation, is 1/2 f double prime at a times x minus a squared. So all I did was come back up here and replace, oh, that's a big one. Make that smaller. We're just going to replace the a and the b and the c with what we found here, a, b, and c, and then write out our polynomial. Okay, so if we know the derivatives of our f of x function, then we can write a quadratic polynomial that approximates that function near x equals a. All right, so that's summarized here in this box. It should match what I just wrote down. And so I'll meet you in the next video, and we'll do an example of where we're going to use that quadratic approximation.